This is the panel for power and power factor measurement of single phase trainer. In this panel, we are giving a variable AC supply, a digital voltmeter, 500 volt AC, a digital current meter, and a power factor meter. This power factor meter is a single phase power analyzer in which you can watch power, voltage, current, power factor, line frequency, and every other parameters. And there are three different loads provided in the system. This switch is able to control these two bulbs. This switch is for these two bulbs. This is a inductive load. This switch will convert L1, L2. This switch will connect L3 and L4. This switch is be able to control two capacitors. Now what we are trying to achieve is, we will show you the effect of a purely resistive load on the power factor system. Then we will start a RL load, in which resistive load and inductive load. Then we will see the change, and then what we will do is, we will switch on the capacitive load and observe the change in the power factor because of using a capacitor. We will see that the power factor will become capacitive and it will come as close to 1 as possible. So let me explain you the connections right now. In the variable AC section, we will connect the neutral, then we will connect the phase. Then what we will do is, we will connect the phase of the voltmeter to one point of the current meter and the other point of the current meter input of the power factor. The wiring is done such that these two terminals are the input terminals, these two terminals are the output terminals, and we have connected the neutral. Now what we have done is, we have connected the C terminal to the inductive load, and the inductive load is in parallel with the capacitive load is parallel with the resistive load, and all the neutrals are also shorted. So when you have understood the wiring, so after making sure that all the terminals are tight, let's switch on the panel. It will take 3 to 5 seconds for meters to settle down. Then what I'll do is, I'll set it to 200 volt, 220 volt AC. Now that I have set it to, let us set it at 230 volt AC. Now that I have set it at 230 volt, let's switch on the resistive load. I have made this meter to indicate the power factor only. Now that I have switched on the resistive load, as you can see, the current, it is 1.51 and the power factor is 1 because it is a purely resistive load. Now I am switching on the inductive load. As I have switched on the inductive load, my power factor has gone to 0.83. Now to reduce this error, what I am trying to do is switch on the capacitive load. As I have switched on the capacitive load, as you can see, it has gone to capacitive and 0.99, which decreases the power consumption, and it is the improvement of power factor using a capacitive load, as we are doing in this experiment. So this is the complete working of the panel. To switch off the panel, you have to follow this procedure. First of all, switch all the loads in the same sequence in which you have switched on. Then reduce the variable to 0, switch off the main supply, and this is the complete experiment.